Hi everyone. The first thing I'm going to do is a general overview of conics and how do you determine between a parabola, a circle, an ellipse, and a hyperbola. So I'm just going to do a quick little run through the first few problems. Number 1, x squared, y squared. So it's addition, which means it has to be either an ellipse or a circle. There are two squared variables, which means now, that tells you it's an ellipse or a circle. The fact that both coefficients are the same, that's 1x squared, 1y squared, so that tells you that this is indeed a circle. Oh, let me try that again. Haha, rumor has it I can draw perfect circles on this app. Okay, so let's go to the number 3. X equals 1/4 y squared minus 2y plus 3. This absolutely 100% must be a parabola. X is to the first power, y squared is to the second power. There is one squared variable, so this is either a parabola that opens up or down or right or left. Because x is the singular variable, so that's x to the first, this must open either right or left, and because the coefficient on y squared is positive, this is a parabola that opens to the right. And number 7 follows the same guidelines. Number 7, again, it is x to the first, and then it's y squared, obviously that's to the second. One squared variable makes it a parabola. So this parabola opens either up or down or right or left. And because the coefficient on y squared is negative, so x is right left, and then the coefficient on y squared is negative, so this opens to the left. Okay. Lastly, we have number 5, so we're going to get an example of just about all of them. Number 5 has subtraction. Automatically overrules everything. This must be a hyperbola. It's hard to know straight out if this opens up, down, or right, left. You need to complete the square to figure out that information. So just by glance, y is negative, x is positive, positive 4, negative 1. X is positive, therefore this hyperbola should open right left. That might change depending on what happens after you complete the square, but just from looking at it at a glance, this would be a right left hyperbola. Okay, so let's find an ellipse. Number 2 is an ellipse, and the reason why number 2 is an ellipse, so you have 9 and 1. So the coefficients do not match. Two squared variables automatically cannot be a parabola. Two squared variables cannot be a parabola. It can't be a hyperbola because it is addition and not subtraction. So the addition right there rules out that it's a hyperbola. It must be an ellipse because the coefficients on x squared and y squared are different. So it has to be an ellipse.